Okay, guys, continuing our discussion about relations, we're now going to ask a special question. So, some relations are what we call functions and some are not. And what we want to know is this a function? So, that's a question. So, is this relation specifically, for example, this one, a function? So, what does it mean, a function? So a function means that if you put something in the function, think of function as a machine. It has an input and then it spits something out. So for example, you put apples and sugar in the machine and it spits out applesauce. Okay. Now, what has to happen for any function is that if you put an input into it, it only can come up with one output. So it's gonna only make applesauce. It's not gonna also make jam or I don't know what else. But it has to be only one thing. So it's just one machine that spits out only one thing, right? So whenever for a function there is an input, there can be only one output. So that's the definition. So for each input, there is only one output. Now, how do we know when we look at the relation? Oh, that shouldn't be a question mark. Just, come on. Let me see. Right. Okay. So how do we know when we look at the relation if it's a function? Okay, so what I want you to do is just concentrate on the x values only. Okay, do not concentrate on the y's. So when we were looking at the x values, is it possible that any of the x's were repeating? And if they are, were they giving you a different y? So I have this situation right here. So look at this guy and look at this guy. Do you see how you have two x's that repeat, but the corresponding y's are not repeating? So you're taking this machine, you're putting 2 in there, it outputs 5, but it also outputs -3. So if any of the x's repeat, that is not a function. So that's why this is not a function. So this first relation is not a function. So this right here, not a function. X is repeated, and that's not good. Okay, so that means it's not a function. Okay, now let's take a look at this right here, this example. So what I'm looking at is only at the x's, and I'm asking myself, are there repeated x values? If they are, then that's not good, it's not a function. So I'm looking at anything that repeats. So I've got -2, I got -1, I got 2, I got 3, I got 0, I got -3. Nothing repeats. So if nothing repeats, that means it is a function. It is a function. No repeats on the x. So no repeats on x values. And if there is repeat on the y's or not, it makes no difference as far as it's a function. It could repeat y's. That has nothing to do with it. It's okay. So that you don't look at, you only look at, was there a case where when I was writing the domain, I had to like exclude something because it was already there. If that's the case, then it's not a function. If it's not the case, no repeats in the x values, then it is a function. Okay.